Just check. So, good morning everyone. Welcome back to NEET World. So, in this session, we will be discussing hydrocarbons. Okay. So, this is our first session on hydrocarbons, and in the last session we have covered the GOC, that is the particularly I can say electronic effects like inductive effect, mesomeric effect and hyperconjugation we have covered, and its application also I have discussed right now. So now in this session we will be discussing the hydrocarbons completely using PYQ questions of EAPCET. Okay, and also along with this EAPCET questions I will be showing some NEET and JEE questions. Okay, right. So now first of all, what exactly hydrocarbons? Okay, so just tell me what you know about hydrocarbons. See, we know hydrocarbons are the compounds, organic compounds which are made up of carbon and hydrogen atoms only, right now. So these hydrocarbons can be classified as saturated and unsaturated. So what I am saying, this can be classified as saturated and unsaturated. Okay, now saturated means we can get the example here we can consider is alkanes. Okay, so alkanes are saturated hydrocarbons, whereas unsaturated hydrocarbons means you can get alkenes and alkynes, right now. So these are the things we have. Now tell me what is the general formula of alkanes. So we have a general formula of alkane as CnH2n plus 2. Okay guys, listen here, one of the very important chapter of EAPCET, JEE and NEET exams like hydrocarbons, because most of the reactions are with alkenes where we study right now, whether it can be haloalkanes like alcohols, phenols, or with any other chapter like carboxylic acid, aldehydes, ketones, anything that has some connection with this hydrocarbon. So what I am saying here itself I will cover maximum quantity of organic chemistry here, I mean important reactions of these hydrocarbons, particularly alkenes and alkynes also. Okay, especially alkenes like ozonolysis, very important now, this kind of reaction, hydroboration. See, using hydroboration we can prepare alcohols. Okay, and ozonolysis we can prepare aldehydes, ketones, and carboxylic also by oxidative ozonolysis. Okay, like that we have many applications from this hydrocarbon chapter itself. So it is very important, and you can expect 2 questions directly from this chapter, and there are connections of this chapter with other organic topics. That's why it is very important to understand hydrocarbon chapter very effectively. Okay, right. So let me check everything is clear or not. Just my voice, everything is clear now. Just mention is voice, video, audio, everything is clear or not. Yes, if this is clear, let's continue our discussion. Yeah. So what is the general formula of alkanes? So we have it as CnH2n. Now alkanes contains only sigma bonds. What I am saying? Only sigma bonds are present. So give some examples here. So simplest alkane possible is methane. What I am saying? Methane. And the second 2 carbons containing alkane is CnH2n plus 2. So n value 2 I am writing here. So H2n plus 2, 2 to the 4 plus 2, 6, C2H6, like that. C3H2n, it means 6 plus 2, 8 now, C3H8. This is propane, ethane, methane, like that I have written here. Okay, right. Similarly, these alkenes have a general formula like CnH2n. Olefins are also called as olefins. What I am saying? Olefins, like oily forming compounds. Okay, so CnH2n. So what is the simplest alkene possible? Give one example. So you can say alkenes are possible with a minimum of 2 carbons. Between 2 carbon atoms there will be one sigma bond and one pi bond. Okay, so here 2 hydrogens, this side also 2 hydrogens. So you can simply write it as C2H4 is an example of alkene. Okay, now when it comes to alkynes, so the general formula here you can write it as CnH2n minus 2. And give one simplest example possible. So it is also possible with 2 carbons of minimum. Okay, so C2H2n minus 2, it means 2 to the 4 minus 2, that is 2 2. So C2H2, that is ethine. What is that? Ethine. So in case of alkynes, there will be one sigma bond and two pi bonds between two carbon atoms. Okay. So this is the like a format or structure of that alkynes, we can say. Okay. So what is a hybridization in case of alkanes? So each carbon in alkane is sp3 hybridized. What I am saying? sp3 hybridized. Generally, if it is methane, you will be having 109.5 degrees. Okay, a tetrahedral angle, bond angle. Okay, with the tetrahedral geometry. And here in case of alkenes, you have each carbon with sp2 hybridization. Okay, if it is sp2 hybridization, geometry will become square, trigonal planar. What I am saying? Trigonal planar. What is the geometry? Trigonal planar. And when it comes to alkynes, each carbon is sp hybridized. If it is sp hybridized, see one sigma bond, another sigma bond. So it is like a linear, na? So it's like a line. So you can say sp, linear. Okay. So it's very important to remember this thing. What is the hybridizations in each case? See, sp3, sp2, sp. This is tetrahedral, this is trigonal planar, and this is linear. So from this itself, you can expect a question easily. Okay. Yes. Sir, how to remember reagents? See, I have made two simple shorts on reagent previously. If you haven't watched, you can go to the YouTube shorts of this particular channel itself. You can have many short videos containing very important topics covered. Especially you are asking about reagents. Yes, I have covered both reducing agents as well as oxidizing agents that are very, very useful. Just go through this short videos of our channel, this NEET World channel. It will be useful. Okay, right. Again, I will be covering whenever there is a reagents topic. I will be covering. You just stay connected with this channel. I will be covering them in detail whenever the topic comes. Okay, no worries about that. Okay, just stay connected. I think KR Reddy Physics. I hope it is clear. Right. So now what I told you, so carbon with sp3 hybridization, you can say tetrahedral, which is an alkane example. Here alkenes sp2 trigonal planar, which is alkanes like a linear having sp hybridization. So now number of bonds between carbon atoms in alkenes will be 1. How many bonds are there in simplest like this one, like second alkane, I can say second member of alkane family is ethane. So this is having only one bond between two carbon atoms, only sigma bond. Here 2 bonds, here 3 bonds. See, the number of bonds can be called as a bond order. Bond order means what? The number of bonds between two atoms. See, between two carbon atoms in this hydrocarbon, how many are there? 1 here. So what is a bond order in this case? It is 2. And what about bond order in this case? It is 3 bonds, not 3. So like this, you need to give the bond orders. See, more the bond order, greater will be the bond strength. So here more bond order, more bond strength. Okay, so now CC triple bond is stronger than double bond is stronger than single bond. So where do we require more amount of energy to break the bond? Here 3 bonds are there, no? So more energy, more bond enthalpy or more bond energy is required here to break all these 3 bonds. Okay, hope this is clear. Okay, now if I want to compare a sigma bond and a pi bond, always remember pi bond is weaker bond than sigma bond. Okay, what I am saying, pi bond is weaker bond than sigma bond. Okay, so whenever the reaction is taking place, in case of alkenes and alkynes, pi bond involvement takes place before the involvement of sigma bond. So which bond breaks first? Pi bond breaks first when we compare with the sigma bond because of its lower energy. Okay, right. Next thing here is, let us see the discussion once again. What I told you, hydrocarbons. Carbons contains only carbon and hydrogen are called hydrocarbons. Right now, this is a simple discussion. Next, classification. We have saturated, unsaturated. Saturated examples are alkanes. It can be simple alkanes and cycloalkanes. See, saturated means the carbon atom here is completely reacted. It has only sigma bonds, no pi bond. Therefore, alkanes and cycloalkanes are considered as saturated. Okay. Now, alkanes, the saturated compounds are less reactive when we compare with unsaturated compounds. Okay. So, what I am saying, saturated compounds like alkanes are less reactive with compare with these alkenes and alkynes. Okay. Remember this statement. Okay. And then next, one more statement here, unsaturated. So, unsaturated compounds at least contain one pi bond. Along with the sigma bond, at least one pi bond must be present in these unsaturated compounds. Here alkenes and alkynes are best examples for unsaturated compounds. Next classification of hydrocompounds is aromatic hydrocarbons. Like benzene is a best example of aromatic hydrocompound. It is an aromatic compound made up of carbon and hydrogen only. So we can say it as aromatic hydrocarbon. Right now, hope up to here discussion is clear. Right, let us move forward. So what is the general formula given? CnH2n plus 2 is for simple alkenes. Okay, so alkenes are also called as paraffins. So what do we mean by paraffins here? Paraffins are nothing but alkanes only. So they have little affinity towards many reagents. So paraffins, they have very little affinity towards the reactivity. It means if I add some reagents, it won't be much reactive when we compare with alkenes and alkynes. So alkanes are less reactive, therefore we can call them as paraffins. What we are calling alkanes as paraffins, only alkanes. Okay, the next. Now how do we prepare these alkanes? Now from now onwards I am like dividing the chapter, hydrocarbon chapter, into three parts. First one is alkanes discussion, and the next alkenes discussion. Alkenes, first one is alkanes discussion, next alkenes, and the next ines. Like this we will discuss everything separately. So first we are discussing about alkanes. Okay, so now how do we prepare these alkanes? So first method is by hydrogenation of these alkenes and alkynes will get our alkanes. What I am saying, hydrogenation of unsaturated hydrocarbons gives saturated hydrocarbon, that is nothing but our alkane. Okay, so this hydrogenation takes place in presence of a metal catalyst. What I am saying, addition of hydrogen to unsaturated hydrocarbons like alkenes and alkynes takes place in presence of metal catalyst. Okay, it is very simple. What is the catalyst used here? Like nickel, palladium, platinum is used. Okay, what is the reducing agent? Hydrogen gas is used here. So simple example I am taking here. See, I have ethene, C double bond, C double bond, CH2. I am adding hydrogen in presence of nickel, or you can do it presence of palladium or in presence of platinum also. Okay, when we are using this nickel, we require little more higher temperature, but palladium, platinum can take place at normal temperatures also. Okay, so what to do here? So just to this double bonded carbon we are adding this hydrogen right now. So just what happens here, CH2, write as it is, CH2 you are writing. Now what we are adding? Hydrogen. Now so add one hydrogen over here, another one here, that's it. See, sp2 carbon converted into sp3 carbon. Right now what is the hybridization in this case? It is sp3 carbon right now. So alkene converted into alkane. Okay, so what is the reaction? What is the name of this reaction? When we are doing hydrogenation in presence of nickel catalyst, we can call it as Sabatier-Sandrins process. What I am saying, Sabatier-Sandrins process. Okay, so now they will ask which alkene is more reactive. See, which alkene is more reactive? See, I am writing here CH2 double bond CH2. Here I have written one alkene, and the next one CH3 double bond CH3 I am writing, second alkene is done, and third one also CH3 CH3 CH3. So out of this ABC, which is more reactive? Tell me, which alkene is more reactive out of these three? Like for hydrogenation, which is more reactive? So it is very simple. More stable alkenes are less reactive. What I am saying, more stable alkenes are less reactive. So which alkene is more stable here out of these three? See, alkene stability is explained by hyperconjugation. Guys, if you are not knowing what is inductive effect, what is mesomeric effect, and what is hyperconjugation, it is very, very important to know before starting your organic chemistry preparation. Okay, so now I suggest you to watch. If you haven't got clarity on this this one hyperconjugation, mesomeric effect and inductive effect till now, you just go and watch my previous live sessions like yesterday's and day before yesterday's. Definitely you will get complete clarity. I mean, you will get a good amount of understanding on this mesomeric effect, hyperconjugation and their applications also. Okay, so now how can we answer the stability of these alkenes? That is properly explained from hyperconjugation. So what hyperconjugation says, to the carbons, to these double bonded carbons, Adjacent carbons are called alpha carbons. On alpha carbons, if we have hydrogens, those hydrogens are called alpha hydrogens. More the number of hydrogens, more the number of alpha hydrogens, more is the stability of this double bonded carbon by resonance, like hyperconjugation resonance, like no bond resonance. Okay, so therefore here we have 1 2 3 4 carbons, each carbon contains 3 hydrogens, so 4 3s are 12. So there are 12 alpha hydrogens are there. So it means you will get 12 resonating structures, 12 hyperconjugations are possible here. Okay, and here you have 3 plus 3, 6 alpha hydrogens are there, 6 hyperconjugations. Here no alpha hydrogens. So where do we have more number of alpha hydrogens? Here. So it will be more stable. If it is more stable, it will be less reactive towards hydrogenation. So what will be the stability order? Stability order is C is more then B and B is more than A. This is the stability order. Now I am discussing about reactivity of these alkenes. So which is more reactive, just tell me. So this is less stable now. So reactivity inversely proportional to stability, we can say inversely proportional to stability. If it is more stable, less reactive. So this is less stable, more reactive. So for reactivity order A, B, C, this is very important concept to be understood. Okay, I hope the discussion is clear. If any confusions, feel free to express in the chat box. No worries, I will repeat if you want. Okay, now right. Yeah, so whenever there is blur on the screen, you just mention in the chat box, I will make it correct. Okay. So let's discuss few more things here. Yeah. So next we will be discussing about few more things. See here, what are the other points you need to remember here when it comes to hydrogenation of alkenes and alkanes. So what is the catalyst we will be using? Nickel, palladium, platinum. So what is the reducing agent? Hydrogen gas here. Okay. Now remember, addition of hydrogens in this hydrogenation process to the alkenes follows a cis addition or syn addition. What is this cis addition or syn addition? It means whatever the hydrogen atoms we are adding, that should come from the same plane. Okay, it means, let me give you one example here. See, this is an alkene. To this we are adding H2 in presence of palladium, platinum or nickel you can take. So what happens here? To the given alkene, remove double bond and replace the carbon double bond with hydrogens, like this. See what I did here, if you observe, I have removed double bond, I have attached two hydrogens. Both hydrogens are from above the plane only. If you observe, both hydrogens are from above the plane. So if both hydrogens are of same plane, you can say this is syn or cis addition. Okay, or you can add it in the below the plane also. One is below the plane, here also below the plane. So this kind of addition is called cis addition or syn addition. So hydrogenation of alkenes in presence of nickel, palladium, platinum follows a syn addition. Okay, remember this statement, important one. Okay, so what I told you, it's a syn addition. So whatever the things you are adding, that should be comes from same phase, then you can say same phase of the reactant, then you can say it is syn addition. So now tell me, in the given compound, just tell me in the given compound where the hydrogenation takes place easily. So out of this A and B, which position hydrogenation takes easily, like reactivity of this AB position double bonds, which is more reactive, I am asking. Very simple, you can easily answer, tell me. Yes, tell me, anyone? See here, you have a double bond here. Which type of double bond here it is? See, one side you have alpha carbon, another side alpha carbon with 3 alpha hydrogens, here 2 alpha hydrogens, and this side this is alpha, sorry, here you have 2 alpha hydrogens. So totally 7 alpha hydrogens with respect to this A carbon. So 7 alpha hydrogens are there here, okay, 7. And this side, this is double bond, here you have 3 alpha hydrogens and one more is over here to this is alpha carbon, one more alpha hydrogen. So 4 alpha hydrogens in B case. So where do we have more number of alpha hydrogens? In case of A double bond right now. So here it is having more alpha hydrogens, more stability. So which is more stable alkene now? This A carbon is, A alkene is more stable than B. Therefore if it is more stable, less reactive. So reactivity of A is more, then reactivity of B is more. Reactivity of B is more than A. Why I am saying reactivity of B is more? Because A is more stable now. If it is more stable, if A is more stable, less reactive. So this is more stable, less reactive. So it is less reactive than B. That's it. This is what I am saying. So if I give only one equivalent of H2PT, so what happens? That hydrogen comes and react with this B site, not with A site. Okay? Because it reactivity is less now. Because A is more stable, it means its reactivity is less now. Therefore only B will be reactive here. Okay, hope the discussion is clear on this. Next step, how can we prepare? Next method is preparation of alkanes from alkyl halide. Simple, you can remember this one. See, RH is a, see, alkyl halide they are saying now. Let us take alkyl chloride, treat this with a lithium aluminum hydride. So what is this lithium aluminum hydride? It is a reducing agent. Okay, now it will provides hydride ion. So when this hydride ion is provided, now hydride ion, negative charge is there on hydrogen atom, so it can act as a nucleophile now. So where that nucleophile goes, so that nucleophile comes and attack on this R, and this chloride ion Cl minus goes out. You are going to get a RH type of product, like alkane is produced here. So what we got here finally, alkane is produced. Okay, hope this discussion is clear. For example, I am taking CH3, CH2, Cl. Okay, I am treating with this lithium aluminum hydride. Tell me what happens. What happens here? Just replace this chloride ion with a hydride ion, so that you will get CH3, CH2 and one hydrogen here. That's it. Ethane you got. CH3, CH3 is nothing but ethane, and alkane is formed na? Yes, alkane is formed here. Okay, right. This is clear or not? I think it is clear. I think this is clear. Okay, right. Now just tell me what will be the product if I treat a methyl chloride or methyl bromide with this lithium aluminum hydride. Tell me what will be the product formed here. Just tell me your answer in the comment box. Very easy. Here already I shown you. So whenever you seeing like alkyl halides with the lithium aluminum hydride, remove that halide ion, replace with this hydride ion. That's it. Respect to, if it is ethyl, we'll get ethane. If it is propyl, we'll get propane. If it is methyl, it will give us methane. That's it. This is the answer. Okay, right. Now same alkyl halides, see what I am taking, same alkyl chloride I have taken. This can be treated with zinc and in presence of like acid like HCl. H plus I am writing, this can be generally like HCl will be taken here. Okay, just H plus is mentioned also, you just take what? RH will be your answer. So what is the reaction taking place here? See, zinc provides 2 electrons. Okay, when chloride ion goes out, you will get a positive charge on the alkyl halide. The 2 electrons, see, now what happened, the 2 electrons of this zinc is taken by hydrogen, becomes hydride ion, attacks at this R group, then forms a RH. So if it is methyl chloride, we will get a methane. Here also same kind of product formed in both of this reaction, both of this redox reaction. Hope this discussion is also clear. And there is a question, see, in EAPCET they will give four reactions. ABC will be given in which of the following an alkane is formed. They will ask like this: first reaction, Sabatier-Sanders process is given. Second reaction, preparation of alkanes with alkyl chlorides using lithium aluminum hydride. Third reaction, preparation of alkanes using alkyl halides with zinc and acid, okay, like H plus, like this they will mention. So all of these reactions are giving us alkanes only, okay, right. The next discussion here is this is done, okay. Next Woods reaction, one of the very favorite reaction of our EAP set. So definitely one question from Woods reaction only, you can fix it, okay. So either it will be Woods reaction or Woods-Fittig reaction, definitely one coupling reaction will be given, okay. I will be giving you this complete clarity, just look at here. A solution of alkyl halide in ether and heating with sodium gives alkane. So just take alkyl halide, okay, you take alkyl halide, alkyl group halide, and treat this with sodium in dry ether, So what happens is you are going to get a product like, if it is Rx, you will get a RR kind of product. So this is R is nothing but any of your alkyl groups, like methyl group I am taking here, methyl chloride we are taking. Just tell me what happens, what will be the product here. See, same sodium in dry ether. So now what happens, alkyl chloride is there, just remove this chloride. What is the R group here? We have methyl now, so you can write a CH3, CH, that's it. This is a product formed during the reaction, okay. If it is RH, you will get RR kind of product, that's it. And reaction must takes place in presence of dry ether condition only, not in the wet conditions. If it is wet condition, sodium, instead of reacting with this alkyl halide, it will react with this aqueous medium and forms and shows an exothermic reaction and forms like NaOH and hydrogen gas is released. So we do not want that thing now. Reaction must takes place at here only, and this should be coupled to give this kind of higher alkanes from this lower alkanes. Now Woods reaction is very suitable for preparing symmetrical alkenes. So what do we mean by symmetrical again here? See, instead I can say even number of carbons containing alkanes are best prepared by Woods reaction, not odd numbers. What I am saying, it is suitable for preparation of even number of alkanes containing even number of carbons containing alkanes. For example, you can prepare ethane, okay, and you can also prepare butane, but preparation of methane is not possible using Woods reaction. Preparation of propane is difficult, or you can say it won't be a good amount of yield, it will be having very less amount of yield, because multiple products are possible when it is having odd number of carbons in a given alkane. So what I am saying, Woods reaction is very suitable to prepare even number of carbons containing alkane, okay. Remember this statement, okay. And I will be giving you few examples. Just hold here, yeah, just hold on here. I will be giving you some examples. See, you just take 1, 2, 3 carbons are there, otherwise how many carbons are there? 1, 2 carbons are there. Here I am writing chlorine, okay. I am treating with this sodium in dry ether. Tell me what will be the product formed. Very simple. How many carbons are there? 1 and 2 carbons are there now. So just remove this halogen and connect one more 2-membered chain here. So you will get 2 carbons means ethyl, and one more also now. So take one more ethyl and make a bond between them. That is ethyl is nothing but butane now. 4 carbons means 1, 2. See, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. That's it. This will be your product. It is 1, 2, 1, 2, 3, 4. That's it. Butane. Okay. See, now if I am giving you propyl chloride, what will be the product formed? Propyl chloride on Woods reaction forms what type of product? Tell me. Propyl na, so 3 carbons are there, so double that number of carbons. 3 means it will be product will be 6 carbons, so 3 plus 3 6, that's it. So you are going to get a hexane when you take 3 carbons containing alkyl halide, like propyl halide gives hexane, ethyl halide gives butane, methyl halide gives ethane, okay, butyl halides gives octane, like this. Hope the discussion is clear. Okay, discussion is clear now, right? Yeah, next we will be discussing about few more things. So only dry ether is used here. So for example, here I have like this. So what happens, tell me? Sodium in dry ether. What will be the product formed, tell me? Sodium in dry ether. So just what to do? Just remove this chlorine, add this kind of alkyl group, one more alkyl group, like this. That's it. So now what if I take two different type of alkyl halides? See, I am taking Rx plus R dash X. It means what? See, here I am taking methyl chloride and here ethyl chloride. What will be the product formed in this reaction? See, now this Rx can combine with itself, therefore you will get a RR type of product. This R dash X also combine with itself and gives R dash product, and there will be a possibility for a cross combination of these two alkyl groups and gives R dash type of product. Okay, so these are the three different possible products you will get when two different alkyl halides are taken. See, with this example you will get more clarity. Methyl chloride is there, so this methyl chloride can react with itself now, so you will get methyl, that is ethane will be formed here. Next term, this is ethyl chloride, so ethyl will react to form a butane, so you will get like this, and this ethyl and this methyl have a cross coupling possibility and can gives methyl plus ethyl, that is propane now, so CH3 CH2 CH3, propane is formed. So these are the three possible products when we take two different alkyl halides. Okay, hope the discussion again here it is clear without any confusions. Okay, so just make a note of this reaction, like they will give two different alkyl halides are given. What are the possible number of products in this Woods reaction, they will ask. Okay, very simple, make self coupling products and make one cross coupling product, possible way. Okay, that's it. Next, here you know when we take bulky groups, there is a possibility to form alkene product also. Okay, what I am saying, there is a possibility to form alkene product also. Okay, just look at this question first, you will get some confidence like what type of questions are asked in the exam. See, if identify the starting material in the following reaction. See, this kind of product they are saying it is formed this kind of product during the reaction. In order to make this kind of product, what is our starting material to be considered? Okay, so tell me, very simple, how can you consider here? See, we know if there is RR type of product, what we seen here, if it is RR type of product, just we have taken Rx. Okay, therefore these two RR groups are combined. So just breaking this compound, breaking this product into two equal halves, says us which type of R group is mentioned here. Okay, so now just try to break this given product into two equal halves first. Try to break this into two equal halves. See, CH3 twice, CH3 twice. Okay, it is fine. Next CH, here also CH, fine. Next it is CH2 and it is CH2. It means you can break it into two equal halves at this point. Okay, if you are breaking this point, so what we will be getting here? CH2, CH, this side CH3 and this side one more CH3. Okay, so like this we have, and here you can put one halide. All of them are bromos only, so you can write one bromo here. Okay, so now just identify their their chain. So what we have? 1, 2, 3. So you can say 1 bromo, 2 methyl, 1 bromo, 2 methyl, propane is there now. So A will be your first option for the particular question. Hope the discussion is clear again right now. So now tell me, what is a suitable solvent for Woods reaction. What is a suitable solvent for the Woods reaction? So it can be only dry ether, not any of the other things here. Okay, so it should be non-polar. I mean, it should not contain any polar substance. I mean, like water molecules should not be there. Therefore, if it is there, then that will be react with the sodium metal. Okay, that's why we need to avoid wet conditions. Next, we'll be seeing this in the next discussion, because this is not related to Woods reaction. Okay, now can you tell me what is a product formed here? Again, all these questions are related to EAP set only. Just look at this, what they are saying. 2 methyl bromides are given, treated with sodium and dry ether. So what will be the product formed? Simply you can write methyl. That is ethane is formed. Okay, I hope this discussion is clear. They are asking the alkane which is next to methane in the homologous series. What do we mean by homologous series? See, homologous series are differ by this CH2 unit. Okay, so now simply you take methane. What is the homologous of this? You just add this fragment to this methane. What will be getting here? CH4 is there, so it means it will be C2 4 plus 2 6 na C2H6. C2H6 is nothing but CH3 and CH3. So what is the homologous of methane? It is ethane. So homologous of methane is ethane formed here. Yes, which alkane which is next to methane in the homologous series can be prepared from which of the following reaction? Yes, we can prepare it from first reaction. And in order to answer this remaining, you need to have some more clarity on this. Just look at this. What is this 3 and 4 is saying here? 2 we haven't discussed, we will discuss, that is decarboxylation reaction, I will tell you. But see here, H2PD is given. What happens with this hydrogenation with platinumide hydrogenation? So now just we are removing this double bond, writing it as a sigma bond and adding one hydrogen, here one hydrogen. So you are going to get a propane, 3 carbons containing hydrocarbon right now. So but what we need only ethane. So this reaction is not giving homologous to the methane. Homologous must be differ by what? CH2 unit only, not more than that. Okay, then next, if you see this one, alkyl bromide is given and they are treating with zinc in presence of acid. What happens? Remove this bromide and add this hydrogen. Yes, here you have a possibility to form ethane. Okay, so fourth option is perfect, first option is perfect. I am going to tell you this decarboxylation. Just remove CO2 part from this carboxylic acid in presence of NaOH and CaO. That is what decarboxylation. So decarboxylation means what? To remove CO2 gas from the given carboxylic acid you remove. So what is the remaining part? This is CH3 and one hydrogen here. So you are going to get a methane. So methane is not a homologous. Now they are asking homologous to methane. Homologous to methane must be ethane only. So it will be in first option and fourth option. So A 1 and 4 only will be the perfect answer for the question. Hope the discussion is clear. If the discussion is clear, just mention yes, clear sir in the chat box. Yeah. So remaining about this soda lime, I will be explaining now. No worries about that. Next one is what? Franklin reaction. Similar to Woods reaction, Franklin reaction, you just take alkyl halides, treat with zinc metal. So you take 2 moles of this alkyl halides, treat with zinc metal. What happens? So zinc will form, see, if it is methyl chloride, see, Cl with zinc forms ZnCl2 now. Like that we will get a ZnCl2 or ZnX2 type product here. This is a byproduct. Okay, now what is our main material here? Alkyl halide. No? So now if you remove this X, what is the remaining part? Our alkyl groups are there. How many are there? So 2 moles we are taking with 1 mole of zinc. So 2 moles of this alkyl halide combined to form RR type of product. So same in Woods reaction, in Franklin reaction, product formed will be looks same. Okay, so here also remove this chlorine, methyl groups. How many methyl groups? 2 moles you take, by default consider 2 moles. So you will get CH3 like this. So when you take 1 mole 2 moles of this starting material methyl halides, I mean alkyl halides gives 1 mole of product like ethane. See, it is 2 moles of methyl chloride giving 1 mole of methyl ethane. If it is 2 mole of methyl halide, it is giving 1 mole of ethane. Right now, methyl halide gives ethane. 2 moles gives 1 mole. That's it. Okay, remember this thing. Next discussion will be on so next we will be discussing on Coriolis synthesis. So what do we mean by Coriolis synthesis here? So do you have any idea? Very important, this one also. There is a reagent used in this Coriolis synthesis called Gilman's reagent. What is that reagent called? Gilman's reagent. So what is the use of this Gilman's reagent? So Gilman's reagent will be used for preparation of unsymmetrical alkanes, especially what? Unsymmetrical alkanes. Very good way to prepare unsymmetrical alkanes. Okay, yes, we can prepare symmetrical also, but I am saying that one of the best method for preparation of unsymmetrical alkane, because Wood's reaction won't be giving unsymmetrical, I mean odd number containing carbons are not suitable. I mean odd numbers carbons containing hydrocarbons, I mean alkanes cannot be prepared using Wood's reaction, or it won't be a very effective method we discussed. Even if we prepare there, it won't be a effective one, because we will get a byproducts, like major quantity of byproducts are formed there. But we can use this Gilman's reagent using this Coriolis synthesis for preparation of unsymmetrical alkanes also. Okay, for example, I want to prepare propane. So what I am saying, I want to prepare propane, and at the beginning I have only methyl chloride. What I have? Only methyl chloride is there. Now what is the remaining part I want? See, only 1 carbon is there for the starting material right now, but I want in the product side 3 carbons are there. So it means 2 more carbons should be added right now. So for that I can use my Gilman's reagent here, dialkyl. So dialkyl means 2 R groups should be there. Lithium, you can take lithium, cuprate, copper and lithium. Like this we need to take. So here R is nothing but whatever the alkyl part we want, that we should be considering. So how many are there here? 3. Starting material is having only 1. So remaining 2 more carbons are required now. So you can consider this is 2 carbons, that is ethyl, CH3, CH2. Okay, you take this 2 times, CuLi, that's it. This is your Gilman's reagent. Treating with alkyl halides with Gilman's reagent gives this propane. That's it. This is a reaction you need to understand. Okay, for example in the other way I am giving you the same reaction in the other way. Just tell me, in order to prepare this propane, I have starting material as ethyl chloride. Okay, so what I have starting material is ethyl chloride. If this is ethyl chloride, tell me what is my Gilman's reagent here I should use for preparation of this propane. Very simple, 2 carbons are there here in this ethyl. I want 3 carbons, so our Gilman's reagent should contain 1 carbon that must be added to here. So you can use dimethyl lithium cuprate, that's it. This is your Gilman's reagent in the given reaction process. Okay, right, okay. So hope this discussion is clear. Right, let me show you few more reactions. These 2 reactions are again very important. From decarboxylation or from coal based electrolysis, you can expect 1 reaction in the exam, at least 1 reaction in the exam. Okay, right. So now what exactly decarboxylation means? So decarboxylation is nothing but you take carboxylic acid. From where? From carboxylic acid we are preparing our alkenes. From carboxylic acid we are preparing alkenes. Okay, so if this is a carboxylic acid, respective alkane is produced. So now what is the difference here there from starting material to final product? See, there is just a removal of this C double bond O and O. That is nothing but CO2 is removed. So what we removed? CO2 is removed. So what we removed here? CO2. So for this removal of CO2, the reagent used in this decarboxylation is soda lime. That is nothing but CaO plus NaOH. So this combination of calcium oxide plus sodium hydroxide is called soda lime. What I am saying? Soda lime. Soda lime is a reagent used for removal of this CO2 from the carboxylic acid that gives respect to alkane. See, it is very simple. You just remove CO2 and add this R and H. R is nothing but alkyl group, H is normal hydrogen that gives a respect to alkane. For example, here I am writing CH3, CH2, C double bond O, OH. Okay, so I am treating this with soda lime. So now what is the product formed here, tell me. So just remove this CO2. So you are going to get CH3, CH2 and the next H. Okay, that's it. See, ethyl is there, one hydrogen. So ethane is formed, that's it. So just remove one CO2 group from here. So now what is one more important factor to be observed here? See, if the starting material contains 3 carbons, our product is containing only 2 carbons. Okay, because one carbon is removed as CO2 gas. So our starting material contains n carbons, product will be contains n minus 1 carbon. Okay, remember this. One carbon is less in the product side compared to the reactant side in decarboxylation reaction. Okay, in decarboxylation reactions. In these decarboxylation reactions. Next, now just tell me what will be the product here. Benzoic acid, when treating with CaO plus NaOH. Tell me what is the product formed. So what I told you, just remove the CO2 part. Just remove the CO2 part, you will get benzene. What is the product formed? Benzoic acid gives a benzene. Okay, right. Hope the discussion is clear. Next one is coal-based electrolysis. After discussion of this thing, I will be giving you some questions from EAPCET. No worries about that. Just listen this. So coal-based electrolysis. Coal-based electrolysis. So now what happens in coal-based electrolysis? See, electrolysis means what? We are breaking the molecules, electrons here by usage of current or electricity. For example, I am taking salts, carboxylic acid, salts of carboxylic acids, like salts of carboxylic acids, okay, like sodium salts you can consider, see, or CO, O minus, NaS, Na plus. So this is sodium salt of carboxylic acid. You can do the electrolysis process for this. Okay, so when we are doing electrolysis process, during the electrolysis, it means what is this process means? Electrolysis process means you have a battery here, so from which you are passing electricity into this solution, this electrolytic solution. Now what happens? So now we have anode and we have cathode, right now. So at the anode oxidation takes place, at cathode reduction takes place. These things we know. Okay, so now at anode, so anode is a positive half, so there all this negatively charged species, what is the negatively charged species here? CO, minus will be moves, okay, to the positively charged electrode, positively charged metal rod. This negatively charged ions will be moving, okay, because opposite charges attracts now, right. So this will be attracted towards a positively charged electrode, okay, that is anode. So there what happens is when we passing this electricity, this breakage of this negative charge, like electrons is released, like CO dot will be formed and one electron is released. Okay, and from this how many electrons are there with this oxygen? Now 1. I can say radicals. Radicals are highly reactive now. So now what it will be doing is it will be taking an electron from this RC bond. Okay, this electron and this electron will be paired up and will be giving a R radical plus a CO2 gas. So what is released here? CO2 gas. Where electrons are releasing it? Anode. So removal of electrons is nothing but what? Oxidation only, no? Yes, we removed electron. So oxidation is taking place where? Oxidation is taking place at anode, remember. Okay, now what are the products formed? Our radicals are formed and CO2 gas is also released at anode. Very, very important. So CO2 gas is released during core-based electrolysis. At which electrode? Anode electrode. Now these R radicals, see, like this R radicals are nothing but if it is methyl group, we will get methyl radical, right now. So like this, there will be n number of methyl radicals are formed now. If I take n number of these carboxylate ions, we will be getting n number of this methyl radical, right now. So if this n number of methyl radicals are formed, all them are coupled with each other now, so that gives, like if I take two methyl radicals, now they are combining like this and gives a methane, like methyl gives a ethane kind of product. So hydrocarbon formed will be at anode only. Okay, CO2 gas released is at anode only. Oxidation is taking place at anode only. Remember these three statements. Okay, so now at cathode, what happens? At cathode, all the cations are attracted. What are the cations we have? See, Na plus ion is there at cathode. At cathode, you have Na plus ion. Okay, and this is silver salts of carboxylic acids. See, this carboxylic acid solution, no? So it means silver salts of carboxylic acid solution means along with this Na plus, we have H plus ion that comes from water. Okay, right. So now out of these two ions, H plus ion undergoes reduction at cathode by taking these electrons which are released at anode. Okay, so 2 H plus ion, 2 electrons forms H2 gas. Now one more important point is hydrogen gas is released at which electrode? At cathode, hydrogen gas is released. This is a JEE advanced question, I think so. Mains are advanced, I am not having complete clarity on it, but we have a question, PYQ question on these three statements only. In coal-based electrolysis, H2 gas is released at anode. In coal-based electrolysis, H2 gas is released at cathode. In coal-based electrolysis, CO2 gas is released at anode. Like this, they made 4 statements. Very easy. H2 gas at cathode, CO2 gas at anode, product formed is at anode, and oxidation taking place at anode, reduction taking place at cathode. That's it. These are the 5 points. Make a note from this. Okay, and how can you identify final product formed? See, given carboxylic acid is there now, remove that CO2 part. And what do we have here? Alkyl group is there now. See, whatever alkyl group is there, just double it. If it is R group, make it RR type of product. Okay, so if it is methyl, we get ethane. If it is ethyl, you will get propane. If it is propyl, you will get a hexane. Okay, hope the discussion is clear. Like, look at the alkyl group, just double the alkyl group. That will be your product in the coal-based electrolysis process. Okay, hope the discussion is clear. Now look at this, sodium acetate on coal-based electrolysis gives ethane. So what do we mean by coal-based electrolysis? Yes, just now we discussed sodium acetate means what is the structure, right? CH3 COO minus Na plus. This is our sodium acetate. So now what we need to do? Coal-based electrolysis. So coal-based electrolysis is nothing but this CO2 part you remove, whatever the alkyl group is there, that will becomes double CH3. Yes, this is perfect. Ethane is formed. Yes, statement assertion is perfect. And methyl free radical is formed at cathode. No, methyl free radical is formed at anode only now. This is the negative part. See, after removal of this, we will get a CH3 radical. That CH3 radical only combining to give a ethane kind of hydrocarbon, right now. So this complete process is taking place at where? Anode only now. So complete oxidation, formation of radical, formation of product is taking place at anode. So reason is false, assertion is true. Okay, so what I can say, A is true, B is false, R is false. So option C will be your answer for the question. Hope discussion is clear with this particular example. Now just look at this. Till now whatever we have studied, all those questions, all those concepts are included in this question to give a particular question here. Just tell me what is the first answer, which of the following reaction gives product with less number of carbon atoms in the starting material. Yes, look at this. So less number of what is this reaction? Alkyl halides sodium in dry ether. It's a Woods reaction now. So Woods reaction gives what? RR type of product. See this carbon, see here carbons are not less, carbons are doubled. It is a lower alkyl group becoming a higher alkene. Okay, so here not carbons carbon is not lesser than the starting material, it is more than starting material. So not the first option. Choose the second option. See here soda lime is given. So what happens in soda lime? We are removing CO2 from the starting material now. If we are removing CO2, one carbon is less from the starting material when we compare with the product. Okay, we will get RH type of product. It means one carbon is less in the product side compared with the reactant. Okay, so it means definitely option 2 is correct. Now during the electrolysis what happens? You are removing what we are doing here. You are just taking this alkyl group of this carboxylic acid salt and you are doubling it. It will be giving a RR type of product. See here also lower alkyl group converting into higher hydrocarbon. So here carbon atoms are not getting less, they are increased right now. Okay, it means suitable answer is B. And see here zinc and HCl, reduction of alkyl halides. What happens? Just remove X and in the place of X you will get a hydrogen like H. So you are getting a RH. Same number of carbons in reactant and product in case of reduction of alkyl halides using zinc and acid. Okay, so where do we seeing the less number of carbons? Only in option B. That will be your answer for the question. Okay, hope the discussion is clear, like everything is clearly discussed without having any confusions. Okay, right. Next, okay, this question you need little more time for the discussion, and tell me for this. Can you give me your answer for this? Again, see similar model question in JEE and also in EAPCET also. Yes, I hope you will answer this. Yes, you can answer that. No problem at all. Very easy. Yes, I am expecting answer in the chat box for this question. So what to do here again? In coal-based electrolysis, sodium propanoate. So sodium propanoate, how many carbons? Propane means 3 na, propanoate, take 3 carbons, CH3, CH2, CO, OH, sodium propanoate. Okay, so these upon coal-based electrolysis, coal-based, okay, product formed at anode and cathode are. See what happens to this product, like this reactant on coal-based electrolysis. See ethyl group is there, alkyl group is our ethyl group, that will be couples with itself, gives a butane kind of product. So CH3, CH2, CH2, CH3. This is our product. Okay, where it is will be formed? It is formed at anode. This is at anode. Along with this, CO2 gas is also released at anode. These are the two things happening at anode. And what about cathode? Hydrogen gas is released at cathode. Okay, reduction at cathode. Okay, that's it. Now based on this, the products formed at anode and cathode are, see C2H6, yes, is this C2H6? No, it is a butane now. So C4H10, C4H10, yes. See product C4H10 is formed at anode, and the next at cathode hydrogen gas is released. So C option is perfect for the question, right. Hope the discussion is clear on coal-based electrolysis. Now a mixture of ethyl iodide and N-propyl iodide is subjected to Woods reaction. The hydrocarbon which will not be formed is, see what they are taking here, ethyl iodide, N-propyl iodide. Okay, so ethyl iodide means 2 carbons are there, and propyl iodide means 3 carbons are there, propyl iodide means 3 carbons are there. Okay, so when ethyl iodide undergoing self coupling reaction, you will get ethyl product, that is nothing but butane is formed. Okay, when propyl is undergoing self coupling, you will get propane means 3 carbons, so double it 6. So you will get a 1 2 3 4 5 6 carbons containing hydrocarbon. Okay, you will get butane and hexane. Okay, when it is undergoing a cross coupling, you will get a 3 plus 2 5, pentane you will get 1 2 3 4 5, pentane you will get. So butane is perfect, propane no, pentane is perfect, hexane is also perfect. So which is not possible product here? Propane. Okay, propane is not formed here. That will be your answer for the question. Which is not formed they are asking. So B option is your answer for the question. Okay, right. Next. These are the questions which I am giving you as a homework, and just try them. If you are unable to answer, no worries, I am going to help you in the next session. We will be discussing them in the next session, but by the time you just practice them, look into the notes again, whatever the notes we discussed here, whatever the discussion we have done till now, just go through it again. You can look into this question, definitely you can able to answer these questions whichever I am showing here. Okay, so again, okay, so any doubts are there, mention in the chat box. We will be discussing in the next session, that is tomorrow's session. Okay, so thanks for watching. Stay connected to our NEET World YouTube